So today we are going to take a look at equivalent fractions and some strategies that we can use to find equivalent fractions. Okay, so here's what we are going to be using. Now I'm going to show you how to do this by drawing it and with a number line. However, I prefer that we're using manipulatives because the manipulatives make it really easy for us to be able to see exactly what is happening. Okay, so I'm going to be using manipulatives that I printed. It was one big sheet. It has the different fraction pieces that were all lined up, and I just cut them apart. Okay, so this paper is linked at the top of the page where you found these videos, and then you can also, that's where you can print it from. You can also use the virtual manipulatives. There is a link also at the top of the videos page for the virtual manipulatives, or the best thing that you could use would be the actual physical fraction strips manipulatives. And if you would like to order some of those, they are available for purchase on Amazon. You can find them there. If you're going to use the printable one, I just have it printed on regular paper and I did not color it. However, I would recommend, if you have the ability to print it on cardstock or laminate it, you're doing one of those things because you're going to be using these a lot, and so you'll just want to make sure that they are, kept in nice kind of flat condition. And also, if you color each fraction part a different color, that makes it a lot easier to look at. Okay, like I said, I just printed it and cut it apart, so you can see it's definitely doable this way. Just kind of giving you some tips to help make it a little bit better. All right, so when we're talking about equivalent fractions, we're talking about two fractions that represent the same part of a whole. So let me give you a scenario before we dive deep into this. Let's get a scenario where we would have equivalent fractions. Okay, so I have a sandwich and I've cut my sandwich into two pieces. So that means I've cut it in half, right? And I have two halves. Let's say, so one piece of that sandwich would be 1/2. But let's say that I wanted to cut the sandwich differently. Let's say I wanted to cut it in 4 pieces. Well, how many pieces then would I need to eat to still have eaten half the sandwich? Let's say Mom says I have to eat half of my sandwich. How many pieces would I have to eat to still eat half of my sandwich? Well, now it's in 4 slices, so I'd have to eat 2. And you may think, wow, you have to eat more. No, my pieces are smaller. If I have a sandwich and I've cut it into 4 pieces, my pieces are smaller, right? And if you guys have ever cut a sandwich like that where you cut it into 4 little squares, each little square is a lot smaller than a half of a sandwich. Okay, so depending on how we're cutting the whole, kind of depends on how we would represent the fraction. Now, we want to be representing the same part of the whole, so the same amount. That's kind of what we're thinking about. Think about this. Here's another example of equivalence where we have different amounts. If I have 5 pennies, I have 5 cents. If I have 5 nickels, do I have the same amount of money? I don't, right? Because the nickels aren't worth the same amount as the pennies. The pennies are worth less, so I need more of them to have the same amount, right? If I have 5 nickels, I have 25 cents. So if I wanted to have the same amount in pennies, I would need 25 pennies because each penny is only worth 1, whereas each nickel is worth 5. Okay, so that's kind of what we're thinking about in regards to fractions. It's not that we are representing the same amount, but we're representing it in different ways, just like you can with coins. You can have 25 cents where you have 5 nickels. You can have 25 cents where you have 25 pennies. You can have 25 cents where you only have 1 coin, a quarter, right? So there are lots of different ways to represent things, and that's what we're looking at now in regards to fractions, but we're representing the same thing. Okay, so let me give you an example, and I'm going to use my fraction strips just to kind of show this. We're going to start out with a half, okay? So I'm going to just show a half in regards to a whole. You can see it would take, if this is, the denominator's a 2, because it would take 2 of these to equal 1 whole, okay? Well, let's see what other fractions would be the same thing as 1/2. All right, I also have little slips that are thirds. All right, if I have one of them, it's not the same amount. I'm going to actually just remove this extra one just so you guys can compare. You see that's too little, but if I have 2/3, that's too much. Okay, so I can't represent a fraction that's the same as a half with a 3 in the denominator. All right, so I'm going to put those away, and I'm going to grab my fourths. All right, so here's 1/4. All right, still not enough. Let's see. Oh, an upside down fourth. I guess it doesn't really matter. There's 2/4. Look, 2/4 is the same as 1/2. All right, I'm going to leave those fourths there since that's the same. I'm going to do my fifths. You see, I'm just kind of guessing. I'm playing around with it, seeing what works. All right, well, 1/5 doesn't work. 2/5, still a little bit too small. 3/5. 3/5 is too big, so I can't do it with a denominator of a 5. All right, so let's try to find another fraction that's equivalent to 1/2. All right, now I have my sixths. All right, so you see my pieces are getting smaller, by the way, so that tells me I'm noticing that as the pieces get smaller, I need more. All right, so with a fourth, I had 2, so I'm going to guess I probably need more than 2/6. Oh, look at that. If I have 3/6, that's the same thing as 1/2. Again, as my pieces got smaller, I needed more of them. All right, I'm going to try one more. I don't have one for sevenths, but I do have eighths. So I'm going to try eighths. All right, again, my pieces are even smaller, which means I'm probably going to need more than 3. How many do you think I'm going to need? Let's see if you're right. So I have 2, 3, 4. 4/8. So right here I have 1, 2, 3, 4 different fractions represented, and they all represent the same part of my whole. They all take up the same amount of space. Okay, 1/2, 2/4, 3/6, and 4/8. They're all the same. Just like 1/4, 25 cents, and it's 25 pennies and 5 nickels are all the same. They represent the same amount. Okay, that's what equivalent fractions mean. Now let's look at how we might use this in our first couple of lessons. Okay, so again, your first couple of lessons in your book, they're going to show you how to do this with drawing pictures and using a number line, and I'm going to show you that as well, but those are not my favorite strategies. I'm going to show them to you because that's what's represented in your book, but I do have a really good reason. I actually love number lines with fractions, and I love pictures with fractions, and we're going to use both a lot, but we have to be really careful. Because with number lines and with pictures, when we're drawing those, it's really important. Fraction pieces are all exactly the same size. And it's really, really hard to draw something where everything's exactly the same size. And so if that is the strategy that you're using to find equivalent fractions, you may think something is equivalent because you've drawn it to be equivalent when it's not actually equivalent. Okay, so that's why I'm really liking the manipulatives a lot better, and I would really like for you to use these fraction strips to help you. Okay, so let's imagine I'm given a fraction, because that's what you're given in your first lesson. I'm given a fraction 2/6. Okay, so I'm going to go ahead and represent 2/6. And I have to find a fraction that is equivalent to 2/6. Now, sometimes you're going to be given a numerator or a denominator. So it's important that you remember what those mean. If you're given a numerator, that tells you how many pieces you're going to be using. The denominator tells you how many pieces there would be to make a whole. Okay, so in this case, let's say I am given a numerator of 1. So I know I'm only going to need 1 piece. Remember, I was just saying if we have more pieces, the pieces are smaller. So if I'm only using 1 piece, here I needed 2. If I only need 1 piece, that tells me that my piece has to be bigger. So let's try a bigger piece. Let's try 1/5. That didn't work. 1/5 is not equivalent to 2/6. Okay, let's try the 4th. Right, I'm looking for my bigger pieces because I'm only using 1 of them. Closer, but 1/4 is not equivalent to 2/6. All right, so now let's try a 3rd. Ah, there we go. 1/3 is equivalent to 2/6. Okay, so I know that those two fractions are the same. They represent the same amount of one whole. Now, let's say that it's the same fraction. We're going to start with 2/6. And let's say that they gave us a numerator of 4. A numerator of 4. Okay, now when they gave us a numerator of 1, we knew that the piece had to be bigger because it takes less pieces. But now the numerator is 4, so now we're getting smaller. Okay, we know we have to be smaller than a 6th. All right, I don't have 7ths, so let me try 8ths. All right, because I know that it has to be smaller if I'm going to have more of it. So let's see here. Can I do 4? I know there would be 4 of them. No, that's too big, right? 4/8 is too much. All right, so now I'm going to try 9ths. You see, this is just a lot of guessing and checking at this point in time. We're going to talk about a strategy. Ooh, look at that, 3/9. That's equivalent, but what did I say the denominator or the numerator had to be? Had to be a 4. So it didn't take 4 of them, it only took 3. So here's another equivalent fraction. I'm going to kind of set that one to the side, but that's not the one we're looking for, right? All right, so it's not 8ths, it's not 9ths. Let's try 10ths. All right, if I'm lining up my 10ths, I don't think I'm going to be able to do 4. I think 4 is going to be too big, right? What do you guys think? Yeah, 4 is too big. Well, I only have one other one to try that's little. It's my 12ths. Do you guys think that's going to work? You think I'm going to be able to fit 4 12ths? Let's see. All right, 1, 2, 3, 4. I am able to fit 4 12ths. So I know that 2/6, 1/3, 4 12ths, and we also discovered 3/9 are all equivalent, okay? Everybody got that? So all I'm using is these fraction strips, and I'm just testing to see what works, all right? And that's where I want you to start, because that's going to help you to build understanding of what equivalent fractions are. And you're also going to start noticing some patterns. You might start noticing that when your denominators are kind of like skip counting, that you're gonna start seeing, oh, well, do I say that number when I'm skip counting? All right, that's going to be a pattern that you're going to notice, and we're going to talk about that a lot more in the next video. But I just want you to know that that's something that you'll see. Now, there are 2 other ways that we can do this, and these are what are covered in your lessons, okay? And that is with drawing a picture or with using a number line. Now, I will tell you, the drawing a picture and using a number line are great things, and we do need to be able to represent fractions as pictures and as number lines. So if I'm going to go back to that same question, 2/6, okay? If I have 2/6 and I want to represent it, I'm going to draw a rectangle. You can draw whatever shape you want, as long as you can split it into even pieces, and I'm going to shade in 2 of them. Now, if I wanted to use my imagination and see, well, if I only split this into 3 pieces, right? Let's pretend that middle line's not there. I only would shade in 1 of them. So 1/3 is equivalent to 2/6. Okay? Or, let's say I wanted to split it into more pieces. Let's say I cut it this way. All right? And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. How many of those are shaded in? 1, 2, 3, 4 12s. Okay? So that would be drawing a picture. You're just drawing the picture and then trying to split it differently than you split it before. Okay? Either by making sections bigger, like we did with those, or by cutting more pieces. But you have to be really careful. Like, I can't just go like this. Oh, now I've cut more pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 8/16 is the same thing. It's not, because I didn't cut the pieces evenly. You see, these pieces are a lot smaller than those pieces. I have to cut it each section the same way. Okay, so when you're cutting the pieces, you just have to really keep that in mind. Again, that's why I like the manipulatives better. All right, the other thing is our number line. So if we have a number line, fractions are less than 1, at least the fractions we're talking about right now. They're all less than 1, so all the numbers fall between 0 and 1. You do need to know how to put fractions onto a number line. So if I'm putting, let's say, thirds onto my number line, I have to split my number line into 3 equal-sized pieces. 1, 2, 3 pieces. Okay? My first piece is 1/3, and my second piece is 2/3. 1 whole is the same thing as 3/3. Do you guys see that? All right, so you notice I didn't draw 3 dashes, I only drew 2 because I'm splitting it into 3 pieces. The fraction is standing for the pieces, not the lines. Okay, that's really, really important. All right, so I've split my number line into my fractions, and right here is 1/3. Let me get a different color pen, and I'm just going to kind of draw a line over 1/3. Now, what if I wanted to split my fraction, my number line, into a different number of pieces? Remember, just like up here, I can't just draw a little dash here and cut it only one time. I have to cut each piece the same way. So let's say I just cut each piece like that. Okay, well now what fractions do I have on my number line? Let's see how many sections I have. 1, 2, 3, 4, 5, 6. Now I have 6 sections. So this would be 1/6, 2/6, 3/6, 4/6, 5/6, and then remember 1 whole is the same thing as 6/6. That's not easy to say. All right, so this section, we have 1/3, 2/6. They fell into the same part. So I know that those two fractions are equivalent. All right, so this would be using the number line, and we're going to use the number line more. I'm going to go into this a whole lot more, but the key with the number line is thinking about how many sections do you have. So I'm actually counting this amount of space, like in between the dashes, not the dashes themselves. 1, 2, 3, 4, 5, 6. Okay, if I have 6 spaces, each dash is worth a sixth. All right, so then I just count up 1/6, 2/6, 3/6, 4/6, 5/6, and then 1 whole is the same thing as 6/6. Okay, so that would be another way to represent it. You can find equivalent fractions using the number line. You can find equivalent fractions using the pictures, but I recommend using the fraction strips to find the equivalent fractions. All right, so that's going to help you with your first 2 lessons on equivalent fractions. And then in the next video, we're going to go through a kind of a mathy sort of way that we can find equivalent fractions. And we're going to be really looking at patterns that we're seeing. And maybe you're already noticing those. So keep those in your mind. If you're noticing some patterns with like the numerators and denominators with equivalent fractions, keep those in mind. All right, because we'll be talking about that next time. Have a great rest of your day, guys. I'll see you next time.